New definitions of trig ratios. So we have learned about the primary trig ratios, sine, cosine, and tangent, and they've all been referenced to a triangle. Now we want to put them in a coordinate grid, XY axis, and we've talked about angles in standard position. We now, with those angles in standard position, want to find the cosine, sine, cosine, and tangent of those angles. So angles that are bigger than 90. Also talked a little bit about it when we talked about the sine law, that there's more than one angle that gives the same sine ratio within 0 to 360, but we didn't really look at cosine and tangent too. So that's what we're coming up with today. So theta is, if we start with theta as an acute angle in a right triangle, so this is basically a review of what we've learned. The trig ratios for those, we call those the primary trig ratios. So that's going to be opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Although you get those on formula sheet, you really should memorize those. So what is the sine, cosine, and tangent of an angle that's larger than 90? What about a negative angle? We need a new definition for the sine, cosine, and tangent ratios to address all types of angles, because you can keep rotating round and round, and we need to basically figure out what those ratios are. So a new definition for the trig ratio of theta, an angle in standard position, involves a point on its terminal arm, so point xy, and r the distance from this point to the origin. Okay, so this is the distance. If we were to draw a right triangle, the r would be the hypotenuse, and theta is the angle that forms with the x-axis there. Okay. If a vertical line is drawn from that point to the x-axis, then a right triangle is formed. So now it's looking like something that we do know how to do. Okay, if the distance from P to the origin is denoted r, then based on the Pythagorean theorem, r squared will be equal to x squared plus y squared, right? This will be the x value of the point P is x, and so that's going to be the distance, the length of that side. Y will be the length of the vertical side, so it's the Pythagorean theorem. So in this triangle, sine, in terms of the coordinates, would be y over that hypotenuse r. So we're, instead of using opposite over hypotenuse, if we've plotted a point so far in the first quadrant, then really we just have to look at the y value and the distance the point is from the origin, so the r value. Cosine x over r and tangent y over x. So tangent, you don't have to know that hypotenuse. These ratios are the new definitions of the trig ratios of angles in standard position. Okay, so this will make it easier for you to do some calculations of trig ratios. And then, as I've mentioned before, when you get to Math 30, you're going to touch on this again and then go into way more detail about it. We're just starting this semester. Okay, so let's take a look here. Here's an example. The point -4,3 defines theta, an angle in standard position. So that means that point is on the terminal arm. Determine the exact value of sine theta, cos theta, and tan theta. So you want to draw your draw an xy coordinate grid or axes and plot the point -4,3. So just estimate -4,3, something like that. Okay, that's going to be on the terminal arm. So if we graph there's our initial arm, there's our terminal arm, okay, so that point is on it. So theta is this angle from here to here. So what do we need to know in terms of our, we know based on, in the first quadrant, Okay, and it's going to be applied to anywhere that you've graphed them. Sine theta is y over r, cos theta is x over r, and tan theta is y over x. So here, now we know what our, this should be vertical. Okay, we can form a triangle. This is -4 for x, this is +3 for y. So that actually has a direction, right? Now we know if the x value is negative, it's not really the length of that side, but it's equivalent to that. And certainly when you're finding the Pythagorean theorem, so we want to use r to get the distance from here to here. So remember, r squared equals 3 squared plus -4 squared. 16, that's 9 plus 16. Got a little switched around there. So 9 plus 16 is 25. And the radius is always a positive. So the x can be negative or the y can be negative, but the r is an actual distance. X and y are really locations. Okay, the distance from there to there is 4, but the location is -4 there. So now we can fill in. Our y value is 3 and r is 5. Our x value is -4, our r is 5. And y is 3 and x is -4. We'd like to show that with the negative out front, not in the denominator. Okay, so out front or in the numerator. So we just simplify it. Okay, so now we found the exact value of sine, cos, and tan. So you plot your point. It's on the terminal arm of theta. Theta starts at the positive x-axis. You draw a little triangle if you need to help you know what x and y are, but you really should know. X comes first in an ordered pair, y is second. You find your r value using the Pythagorean theorem, and you fill it in. Okay. Okay, so the point -6, -4 defines theta in standard position. Determine the exact value of sine, cos, and tan. So very much like the last question. Might have radicals in this based on the information there. So your xy axis, then initial arm, then terminal arm. So -6, -4 would be in the third quadrant. Didn't change the color, just give me a sec. So -6, -4 looks something like that, where you can plot the point first, or then so this would be -6, -4. Okay, and then from there, if you want to form a triangle with the x-axis, it goes up. All right, so your x value here is -6. Your y value here is -4. Okay, so it's in the third quadrant. We still need to know what r is. So you want to use your Pythagorean theorem. R squared equals -6 squared plus -4 squared. Now, if you wanted to use the positive, that's fine, right? These are really, the negatives show you the location, so you know it's in the third quadrant. But when you square a negative, you get a positive. So it's going to be 52, so r is going to be the positive root of 52. 52 is 4 times 13, so that's going to be 2 root 13. So your sine of theta is y over r. So y is -4, r is 2 root 13. So simplified radical means we're going to have to rationalize. So I'm going to multiply top and bottom by root 13. And you'll notice as well, 2 goes into 4 twice. So I'm going to get -2 root 13 over 13. Okay. Then cosine theta is x. X is -6 over r, which is 2 root 13. Same thing, we're going to have to rationalize the denominator, so root 13 top and bottom. And so that's, and 2 goes into 6 3 times, so it's going to be negative 3 root 13 over 13. And then tangent is y, which is negative 4, over x, which is negative 6, and just reduce it. A negative divided by a negative is positive. 2 goes into 4 twice, into 6 3 times. So those are your primary trig ratios for this angle here. This is theta from here to here. So even though it's bigger than 180, bigger than 90 and 180, you're always forming what we call a reference triangle compared to the x-axis. Remember, that's how we get our reference angle, this angle here, by forming a triangle or referencing the x-axis, and that's where we're going to form our triangle from, so that you can see where that r value comes from, the hypotenuse. All right, so this one gives us a trig ratio. Sine of theta is negative 5 over 8. Tells us that theta is in the third quadrant, and we want to then have to find the cos and tan ratios. So draw your coordinate, draw an xy axis, pretty much all the time you do that. Think about what we've just learned is that sine here is y over r. Okay, so we know then that the y value is negative 5. Okay, it tells us that the angle's in the third quadrant. So I'm going to show my initial arm to start. Okay, then I'm going to show a third quadrant angle. I know that the y value is negative 5, so, and the r is 8, so it's longer. So maybe something like that. Okay, and then if I were to draw a triangle with reference to the x-axis, okay, and then that kind of makes sense. This is negative 5 here, right, and so negative 5, and then your hypotenuse is 8. Okay, so we've got that. Now if we have to find cos of theta, we need x over r. Well, we know r is 8, but we don't know what x is. So we can get that though. Remember, x squared equals hypotenuse squared minus the other leg squared. Oops, that's going to be 64. So 64 minus 25, because squaring a negative is positive. So that's going to be what? 59, 39. So x equals, now here's where I'm going to show the plus or minus. We should always show the plus or minus, but when we're using Pythagorean theorem for a distance or length of a side, the last questions, they were always the hypotenuse, which is the length of a side. We didn't need the negative. Now, this x is actually, we don't really care about the length, we care about the location. Okay, this x value here. So it needs to be negative. So we're going to basically cross out the positive. Okay, so it's negative root 39. Can't simplify root 39. So we just fill it in, negative root 39. Okay, and then tan of theta, remember, is y over x. So now y we know is negative 5, x we know is negative root 39, and now we have to rationalize that denominator. So you can kind of see why we did radicals and rationals when we did. So here, so a negative divided by a negative is a positive, so it's going to be 5 root 39 over 39. Okay. That's that one. All right, so in each of the 4 quadrants, so here's an x and y axis, right? State whether each trig ratio is positive or negative. So think about when you're drawing it. I'm going to draw an initial arm, and a terminal arm. Okay, so there's that. So say I have a terminal arm here. When I form my triangle, or any point in here is going to have a positive x value and a positive y value. Your r is always positive. Okay, so a positive x and a positive y. So that means when you're doing your sine, cos, and tan, sine is y over r, so y is positive, r is positive, whole thing is. Same with cos, same with tan. If I were to rotate this and get an angle in the second quadrant, then remember your y value is positive, so that means that your sine will be, okay, so this is positive. Your cosine, well, your x value is negative, so that means cosine is going to be negative. Okay, so I guess I forgot to put in positive here. Yeah, so here your sine is positive, but my cosine is going to be negative. It depends on this. All right, so that's going to be negative. Tan is a positive divided by a negative, so that's a negative. Okay, if we then rotate to an angle in the third quadrant, then thinking about your x value, it's going to be negative. Your y value is going to be negative. Okay, so if we do sine is negative over the radius, which is, or the, we call it the radius, but the hypotenuse as well. It's going to be negative over positive, which is negative. Cosine, negative over positive, which is negative. And then tan is a negative divided by negative, which is a positive. Okay, and then the last quadrant, okay, so if we were rotated all the way to here, then looking at the x and y values of a point on that terminal arm, the x is positive, so that's going to mean cosine is positive. Your y is negative, so your sine will be negative, and a negative divided by a positive is a negative. So if you look really closely at what we just filled in here, in the first quadrant, all of your primary trig ratios are positive. In the second quadrant, only sine. In the third quadrant, only tan. In the fourth quadrant, only cos. So the first quadrant, it's all of them, and then only one of the three trig ratios will be positive in all the other three. So the fast way is to abbreviate. So an acronym: A for all, S for sine being positive, so all positive, sine positive, tan positive, cosine positive. Okay, so now this, some textbooks use the cast rule, starting with cosine, and the bottom right quadrant, quadrant 4. I like to think about it as all students take calculus. And I know that they don't, okay? But I'm a math teacher, so I want all students to take calculus. So the reason why I like this a little bit better is because it's starting with all, and that's what it means in the first quadrant, and then it's rotating through all the quadrants. So this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So that's just my personal choice. Some is add sugar to coffee. That's another way of remembering it. So there's a variety. You have to figure out what you can do to remember. You don't even have to memorize this acronym, as long as you think through everything about the coordinates of your point. Okay.